Welcome to the Droidcon Italy webinar. My name is Francesco Brocero. I'm one of the organizers of Droidcon Italy. Today, you'll be hearing from Enrico Bruno Del Zotto
Hi there.
on nitrogen in your test pyramid. We will be using the YouTube comments for question and answer. Please post your question there. This webinar is brought to you by Synesthesia and powered by Amazon Amplify. Thank you, Enrico. Have a great webinar.
Cheers, thank you. So let's get started. First of all, my name is Enrico and I'm an Android developer in London. This talk is the natural continuation of the talk that I did last year in Berlin, in which I spoke about how the test pyramid is organized, in which manner we can divide tests and run tests in different layers. So just a quick recap in order to be aligned on what we will talk in this presentation. So we spoke time ago about unit integration and end-to-end test, which are tests that are organized again in different levels and can run in different platforms. You can run unit integration and end-to-end in your device, or in the Firebase cloud, or in the JVM emulated machine. So in order to write and run your test, you need to use the Android test library. The Android test, the Google guys are doing a very nice work on it. Of course, you need to write tests which are not this, right? So the Android test library is divided in different parts. We spoke about it in the previous talk. And it depends which layer you would like to test. You need to add the different dependencies. And these are all the list, right? So when you are doing and using the Android test library, one of the main process in which you would like to use this library is not only to write your test, but is, for example, when you are approached to a process like a refactoring process, in which you need to be sure that the feature that you are refactoring will have the same characteristic, the same stuff of the previous one, right? So first of all, you would like to cover this feature with a instrument test, with a UI test, and run it, and this test should pass as well as in the previous, as well as in the feature after the refactoring. So because of you are not Chuck Norris, right, you need to write tests. And what is a good test? A good test is self-descriptive, is simple, and is solid. When I say solid, I mean that the same principle that you are following in your production code, you should follow the same exactly in your test suite. Because, for example, if you would like to write and cover some a part of a feature, right, you need to be targeted. You need to test exactly a portion of that one. So you would like not to write a huge test, right? You would like to arrive directly in a scenario, right? Make and emulate some user interaction and make some assertion. So you would like not to have a test like that, in which you still don't understand what is going on, because the description is very long, so you don't know how to describe this test, and you don't exactly understand what's going on, because you would like to test a huge scenario. So first of all, let's use the KISS principle. So let's keep it simple and stupid, right? And try to test one thing at a time. Don't start with your test and try to follow and cover a lot of condition, right? So try to arrive directly in the scenario in which you would like to test. In this example, we are trying to open directly a scenario in which we are launching a fragment, and we would like to recreate, make the same case in which the screen is recreated. This stuff is very straightforward, right? Because we can use the fragment scenario in this case. And as soon as the screen is recreated, we would like to assert something. In this case, we are asserting that the location and the stuff that is in the location fragment is displayed. So this case is very straightforward. We are just, covering only one thing. And in your test, as well in the production code, you would like to avoid the code replication, right? You would like to use, write your code and use the abstraction principles, and you would like to have minimal dependency. You would like not to have classes in which you have repeat a lot of code and use, the same code in a lot of places. So in order to have that, right, you need to think about your test. How we can say, you need to think your test to be as abstract as you can. What I mean that your test should be agnostic, should not know about what's going on in the lower level, right? So when you launch your test, it should be as well as descriptive as it can, right? So it should arrive directly in the scenario that you would like to test, and again, it should be agnostic. The test should not know about the network, the data layer, the idling resources. This is a thing that you should inject in the lower level, right? For example, when you are mocking your network layer, you would like to have, of course, your resources synchronized, right? You would like that all your asynchronous events are synchronized with your test, because otherwise your test will fail. But this is another responsibility. This is a responsibility of a lower level, in this case, of the network, of the mocked network layer. And so in your test, when you are writing your test, you don't want to arrive to write that level, right, in which you need to synchronize, do everything, right? In order to do that, in order to have this level of abstraction, you need to inject your data. And in the case of, for example, asynchronous stuff, you need to synchronize in case of network data or an asynchronous event. And later on, you would like to have a layer that give you the possibility to make some test conditions, so to run some user action and assert that user action is producing an effect, right, in a very simple manner. In this case, right, so in order to inject our, network data layer, right, you need to hook in your application models. We can see an example here in which I'm injecting a network model as well. So using the mock web server, and it's very straightforward. If you are using a principle like the independence injection here, for example, using Coin, but you can use another framework like Dagger, and it's very simple in order to do that. Again, so you need to synchronize your background operation, and when you are writing your test, you don't want to deal with idling resources, which doesn't mean that you don't need to use idling resources. You should use idling resources because you need to synchronize your asynchronous stuff, but should be done in the lower level, right? And this is for a small example of extraction. In this case here, we have a class that in which we have some function that emulate the user action. In this case here, we use the launch, the app in which, in order to drive the user directly in a scenario, in this case, an activity. And we use another function, right, in order to emulate the screen rotation. In this case, using the same activity scenario. So, and this class, right, can be used in a test, for example, in order to drive the view or to drive the emulator, for example, when the screen is rotated. So after we have the user action, we need a small abstraction in order to let the user test and assert the conditions. For example, here we have a small abstraction on the assertion that you can do in the recycle view, in which we are checking a condition, right? And we are, for example, exposing this with item count. So we can assert that the recycle view, when it's displayed, we can assert that as displayed an expected count of items. So when you are writing your test, you always need to think in this manner. You would like not to write every time this assertion, so you would like to have a bit of abstraction. This is an example. And this approach is very important because of the nitrogen project. The nitrogen project, the scope of the project nitrogen is to have a suite of a library that gives us the possibility to write the same test, and with the same code, we can run it, right, in different environment, like the Firebase Test Lab, the Google Cloud. We can run the same code in the real device, in the virtual device, or in Robolectric, and we should have the same results. In order to do that, we would like to, again, to have a bit of abstraction on what we are writing. And as I told you before, we needed to keep our test and the level of the code of our test in the same quality of the production code. So the test code is not a part of your project in which you are just testing something new, but is a very important part of your code base. In order to do that, we can apply different patterns. We are inspecting now too. So this is a simple one in which we just declaring what the user would like to do. So given a condition, given a scenario in which the test is running, when the user is doing some action, we can assert that that action is producing an effect. This is a small level of abstraction in which we can write a test, an instrument test in this manner. So given in this case a test environment, when the user is launching, for example, the login fragment, so we just recreate the view and we emulate the user action. In this case, we are just writing some text in this edit text, and later on we click the login. We can assert that these actions producing this effect, right? Again, this is a small design pattern, a very simple design pattern. There are a few. This one is the most famous one, which is the testing robot that is very well described by Jack Wharton, and is using the Kotlin DSL, so the power of the domain language of Kotlin, in order to beautify when you are writing some test. And this is an example. Here we are trying to rewrite the same test that we did before with the robot pattern, in which we are just creating this robot that can do some action, and we can, pass in this function in which we are asserting the user. This is the final test in which we just, with the function that we are passing, right, in Kotlin, we can, just set the email and click the login. This design pattern has pros and cons, and it's very easy to read because it's very straightforward. It's very, very, very easy to extend, and it has a very good level of abstraction. We are not dealing with idling resources or mocking network. Again, here we are just hiding that part of level in the test that is very important, right? But there are also some cons. If you write this test, it's not very clear the starting point of the test, and also the assertions here are hidden, so it's not very clear what we are testing. So now we try to modify a bit this pattern in order to make these conditions more explicit, and again, having a better manner in order to assert something. And when we are talking about design pattern in your test environment, we are always referring also to the manner in which, of course, you have organized your production code base. Because when you are writing your UI test, the pattern that you are using can be very helpful, right? So we're talking about MVP, MVVM, and MVI. And for example, if you use the MVI design pattern, everything could be more easier when you are writing your UI test. There is a presentation about an Stoffam that is talking a lot about the manner in which you can use MVI in this in the testing environment, right? And we can, I can present a bit the result of my experiment. The MVI is very helpful because you can expose a state directly in your view. So, and the state of the view is more or less represented by a state machine, right? So we have an explicit state. In this case here, we have the loading, the content state, and the error state. And we have also some action. So the view can be driven in a different state when the user is doing some action, right? So here is an example. And the state is, of course, observed, and so is exposed. And as soon as the user is doing some action, we can use, we can transform the state, right, and drive the view in another state. So we have a single source of truth, and the state, again, are rendering the screen. So in which manner can help this pattern in our test environment? So first of all, what we have to do is to inject the first source of truth and launch the scenario. So in this case here, I'm recreating the activity that we would like to test, and I'm injecting, right, the first source of truth, that in this case, which will be this robot, right? And we can easily write a state verifier, which give us the possibility to double check if the view, so if the state in the view is changed or not when the user is doing some action. So think about, you have your robot, right? You are writing your test. The view is exposing your state, and with in a very simple manner, you can assert, right, if your state, if the next state that you would like to render, right, is the one that you are expecting. So the assertion here is much more better than what we had before in a normal robot pattern. So starting from the beginning, let's try to create this robot, this to-do list robot, in which, first of all, again, we have a state verifier in which we are verifying, we are exposing this relay in which we just emitting the new state, and with an assertion, we just verify if the next assert state is the one that we are expecting or not, right? The good thing here is when the robot is working, right? So when we start the test, we also need a view binder in order to render the state in the view. This is a very good point. It's very helpful for us because in the view binder, right, on the view, we can render the state. And if we are render the state, and we can extend this view binder, we can also do some other very nice tricks. Like, for example, here we have this listener to do list view binder, which is binding the view and rendering the view of the list in this case. And if we are extending this one and we are injecting this one in the view that we would like to test, so in the view in which the robot will work, right? We can also do some tricks like that. So we can, as soon as the view is rendered, we can take some, screenshot, for example, and do screenshots. So we can just assert if the view is rendered, if the dimension of the view is the one that is expected. There are also other framework and library that you can use in this with the scope. But I mean, there are a lot of things that you can do if you are using this level of the abstraction. Here, for example, when you are creating the application module and you would like to create, you would like to create your view, you can inject, as well as you are injecting, for example, in a different layer, the network, the database layer, etc., etc. You can inject directly your view binder that you will use to render your view. So, and you can extend it, of course, right? So again, this stuff is very, very helpful, right? So coming back to one of the first slide, we talk about refactor, right? If you have this level of abstraction, it means that you can write very easily UI test. And if you can write very easily UI test, when you need to refactor a feature, all the process will be easier for you, because you start refactoring and you are expecting that your UI test will fail. So you stop a bit and you just go back to the logic of your feature and you start to refactor, right? As soon as you refactor, you start to write the unit test you start to unit test your logic, right? When this process is passing, you iterate to this process as soon as your UI test again will pass. And as soon as this process is done, okay, you can achieve the feature refactor. Sometimes it's difficult because you can, you can start to work with a huge legacy code. So before start to refactor and before start to do every process and touch the business logic, right? Try to cover with the UI test as much as you can, right? And otherwise, you will finish with a lot of PRs that will be declined. You can lose a lot of requirements of the story, and it will be very difficult for your teammates to follow you in your PRs. So try to arrive before starting the refactoring to a form like that, in which you will have, here we will have a robot pattern in which, given a scenario, so in this case, given a test environment, and have launched a login screen. So when you have a scenario in which the login screen is rendered, and when the user is doing something, so in this case, we are just, setting an email and click login, then, yeah, you will asserting that the screen will render an error. This manner of writing test is very straightforward, and you can easily understand what's going on and very easy to read. So just to recap, a good test suite when you are writing your UI test should be reliable, right? Should be accurate and should fast. So you have not to spend a lot of time to write your test. You would like, again, not to deal with the idling resources in that level. You would like not to deal with the assertion in the recycle view in that level. And again, not to deal with errors producing by different environment, I'm thinking about, for example, Robolectric or Espresso. You would like only to write your test, right? So, and run it and expecting that it passes or not. And It's very important, again, to write the UI test, because especially end-to-end test, as we saw, because this test will cover the user journey in the app. And covering this requirement, so the high level requirement, it means that when the user is using your app, right? So what the user will see means the refactor process will be faster and faster. And it will be better for you, because you know that the requirements of the story, the requirement of that feature, right, are covered. And if you are approaching to a new feature or a new project, try to choose a UI test pattern, right? And based on the architecture that you would like to use for the code base. So if you have, for example, MVVM, try to extrapolate, right, a UI test design pattern that give you the possibility to test very fast, right? So, and if you start a project from scratch, just keep in mind the test per design approach. So what I said before, using an MVI. Of course, I mean, different pattern and different pros and cons, but the MVI give you an end to test your feature. And that's all for me. And so I think that if we have some question.
Thank you, Enrico. Thank you very much. Enrico, now we'll be taking questions shortly. I'd like to once again thank our sponsor, HWS, and let you know that our next webinar will be in September. Hope to see you there. Back to you for the question, Enrico. Enrico, I can see a question from Hamed Khalil. Enrico? We cannot hear you, Enrico.
Sorry, okay, so I was in the other chat. Sorry for your question. Okay, so I'm curious about your testing infrastructure and what tools are you using? So, well, I'm not using a lot of tools. I mean, we spoke at the beginning about the normal Android test library. And so Espresso, of course, right? So JUnit, we have Mockito for the unit test. We are using also Robolectric to run some UI tests in the JVM. And we are not doing tests by screenshot, but maybe in the future. And well, it's a normal test suite. We just try to, especially for my personal project, I just try to have, as we told before, this level of abstraction, right? Also, how long in average does your test run? Well, it depends how many, of course, your test, how many tests you have, right? So a normal UI test, it depends on the manner in which the fragment or the activity is created, the manner, how many dependencies you have, how many mocked dependencies you would like to inject, right? So, and also, of course, where you are running your test, right? It depends, but a normal UI test that is more or less covering a small fragment or a small scenario is around 30 seconds, 40 seconds, just, you know, one UI test. So it depends how big is your test suite, right? And as well, again, also it depends about the test suite, but depends also on the environment. I'm expecting that, for example, if I run my UI test on the Firebase cloud, will be a little bit faster than a small cloud that I have created at home, for example, or a list of devices that are connected to my Android Studio, right? So we spoke before in the last presentation about Robolectric that everyone, especially in the community, expected that our test will run faster using Robolectric and the emulated JVM. In some cases, it's not like that. Since that in some cases it's not faster as Espresso, sadly, and also there are a lot of incoherencies, a lot of differences if you are using the same code. So I hope that in the next year, because we was expecting that in this Google I/O, Google was releasing something. At least if you are following the Android Test the Android Test GitHub project, right, you will see that a lot of comments, especially in this period. But we still have not a lot of news. What I can, what you can find is something that you have directly, in the source code, right? Which device farm service are you using, Firebase Test Lab or Amazon Device Farm? To be honest, I have worked with the Firebase Test Cloud in my current job. Unfortunately, we have some plan to use some cloud. Is still to be decided, but it's something that, of course, in the future can help us a lot in the all automation, QA process, etc. Because a lot of companies currently are still using and doing manual tests, right? So if you can work very close to the QA team with the automation team, maybe you can use and having a good test suite, maybe you can also let them write some tests, right? So that can be a very huge process in the very big step in the deployment process, right? And well, also think about we spoke about Robolectric and Firebase Test Lab. Robolectric was very with lot of things, because in the Robolectric you can emulate a lot of devices. So I have tried in the past to emulate a sort of family of devices, like having a tablet, small screen sizes, etc. But because of the view is not properly rendered, but it's only emulated, sometimes the assertion that you are doing is not totally reliable. So you can have some false positive. And well, I'm expecting that in the future, this framework can be more reliable and maybe more compatible with Espresso, right?
We have a new question from Triat Bumin. It says, nice topic. Do you have any sample code repo with full of tests?
Yeah, sure. I mean, there is some code in GitHub with this MVI test pattern that I used for this presentation. I have to push the last code that I did, but I will do it in the next couple of days. But you can refer directly to my personal GitHub repository and the project which is used in Maverick, which is an MVI design pattern and framework developed by Airbnb. And in that project, you can find the first design pattern that I showed you. So the first one, very simple, in which you are using given, then, and when. And there is also some code about the new UI pattern that I showed you with the state verifier and with that kind of abstraction.
Thanks again, Enrico.
You're welcome.
Thank you very much for your webinar. Hope to see you in Droidcon Italy conference on the 27th and 28th of November. Thank you.
Thank you all. Cheers.
Bye.
Bye-bye.